Today we're talking about Earth history and geologic time, continuing our discussion from tectonics, looking a little deeper into the different rock layers present on the tectonic plates. So you maybe have done something similar to this way back when you were tiny, kindergarten or first grade, where you've been asked to put events in order, thinking about what you know about each event, not having any kind of time frame, but just thinking about how do I know which comes first, second, and third. So here we can see some people working on making a cake. If you were to determine which happened first, second, and third, what order would you put these pictures in? Well, maybe if you haven't baked a cake before, you've for sure eaten one or seen someone else do it. So hopefully you would recognize here that this would be my step number one. I would be mixing the ingredients together to create the cake first, followed by putting those ingredients together in the oven, and finally enjoying my cake. We're going to be doing that same kind of thing with the rock layers, thinking about what rules do we know that form rocks rather than rules that form cake. Okay? Now, scientists do this every day. One of the most common places to think about geologic history would be here at the Grand Canyon. Looking at all the different layers, seeing all the history stored up within all these layers, trying to figure out what happened first, second, third, and really what happened to make this entire landscape that we can see in Arizona. So when we're talking about relative time, here's what we need to know. Relative time is just what we did with the cake example. We are trying to determine an order that rock layers or events were deposited. Okay, we are trying to figure out the order those rock layers or events were in, and as we figure out that order, all we're using is what we know about the event. We have no dates that we're using. Okay, no dates are being used, only what we know about this event. So here, this is my relative timeline of events that I remember in my life, but don't remember an exact date for some of these. So one of my earliest memories here is a family vacation to Disney World. Okay, I know it was just me and my parents. We were a three-person family at the time, so sometime after our vacation is when we added my sister to our family. There she is. She's so cute. Okay, once she was around, sometime after her birthday, I spent the summer on crutches, broke my ankle. Once the ankle was healed, we had another family vacation here to the East Coast, looked at a lot of lighthouses, and then I really got serious in my golf career through middle school, high school, and college. I was on the golf team, finally graduated college, got my teaching job, made piles of money, got married, and then, of course, had my little baby there. Now, I do remember dates of some of these events. Of course, I remember her birthday, when I got married, and when my sister was born, but I don't remember the exact dates of some of these other things. So I can use that information about what I know about them to put them in that chronological order relative to each other. Okay, and that's where the relative date names comes from. Okay, I can put them relative to each other. I have no dates to use, just what I know about each event. Now, in terms of something called absolute time, we will be determining special events happening in the rock record. I'll order both events and rock layers. And here, when I'm talking about absolute time, here I'm going to be using actual dates. And I can find the actual date of a rock or an event from something called chemical composition of the rock. So I can actually look at the chemistry of the rock and figure out a time frame when that rock occurred. Okay, again, that's only in absolute time. For relative time, starting out today, we're just putting events in order. So at the beginning, I asked you to put relative time, your cake examples, in order. But if I were to add absolute time, I might notice a little clock in the background. And that clock might say 1 o'clock, that might say 12:30, right, and 12:45 or something, right? So the time might give it away, and that would be absolute if I have the actual time in there. So in order to start understanding our relative time of rocks, we have to know a couple rules. And these rules are pretty basic. However, like everything in science, they have kind of a fancy name. So here, this first one is called the principle of original horizontality. And I want you to kind of pull out that keyword in there, horizontal. Right? We know that horizontal is a flat direction, right? Like the horizon. Now, because it has that fancy name, we like to break it down, and sometimes we give it a shortcut name. And our shortcut name here is the rule of cake layer. So we're going to keep thinking about cake. What this rule tells us is that all rock layers must have been horizontal when they first were formed. Okay, they must have started out horizontal when they were originally deposited. We can see here in this cake picture, all the cake layers are perfectly horizontal, right? That's how the cake should be. Okay, but things can happen to a cake. It can fall off the table, you can be carrying it and trip, you can transport it in your car, get it turned over. Things can happen to the rock. So even though they start out horizontal to begin with, they don't always look that way forever. And we can see here they've been tilted and some new have put on top. So on the side of your notes there, you have that little square to kind of draw a picture of what this rule represents. What I'd like you to do is basically draw these two pictures together. So your box is going to be kind of like a before and after. Okay? So your box, you can put a little squiggly down the middle. You can label this side the before. You can label this side the after. And here we want to show they were originally horizontal, just like the rule is telling me. They had to start that way. So I'm going to draw in some nice flat layers.
Delicia Coleman to the main office, please. Delicia Coleman to the main office.
And then here, the after, I want to put in a tilt.